warm round of applause for Naomi and her talk about event-driven evolution.
Which hand do I hold? Thank you very much, Dave, and it's great to be back here at PHP UK. Thanks to all the organisers for once again putting on a great conference. And I, for one, love an interesting conference venue. And who could have failed to notice that massive piece of Roman wall that's surrounding us today? A true example of modern construction built around but also embracing its legacy. And whilst that Roman wall might have a legacy of 1800 years, today I'm going to talk to you about a Laravel application with a legacy of a mere 10 human years. Although in computer years, it's more like 200, so it's sort of a Victorian era infrastructure project. But yes, this Laravel application is a legacy monolith by our definitions. It has evolved with the business that it serves over time. It has its fair share of technical debt. Would we call it award-winning? Well, to coin Gary's phrase, it depends on who you ask. Because whilst this application might not be winning any awards for clean code anytime soon, last year, this Laravel application put through the sale of over £1 billion worth of gift card sales. So it does depend on who you ask. Welcome then to the real world of successful software development. One of compromise, one of adaptation, and one of evolution. And I'm hopeful that some of you here will resonate with this picture because it likely means that you're working for a company that is doing something right. And it also likely means that your job gives you the challenge that is worth getting out of bed in the morning. The type of challenge that puts the word engineering in software development. And today I'm going to talk to you about a few of the challenges that I and the team I work with at Tillo have been facing and tackling over the last year, alongside our new partner, AI. My name is Naomi and I'm a lead engineer at Tillo, a global gift card network connecting buyers with brands through our gift card API. And this is Arnie, our armadillo mascot. He's very excited to be here as well. Outside of the world of gift cards, I am a big Formula One fan, I am a crafter, and I am also an adult fan of Lego. So you can feel free to talk to me about any of these things as well. But back to the work stuff, and for the last 5 years, I've been working with the team at Tillo on our core Laravel application. I've helped the product evolve, and I've watched the company grow from strength to strength. Throughout that time, and actually throughout my entire career, the software development landscape has changed massively. Gone are the days of 20 years ago when I'd be editing a file on a live server in QFTP, hitting the save button and causing a production white screen of death because I forgot a semicolon. That pace of change has kicked up several gears just in the last year as the AI has taken the software development world by storm and caused more hype than I've ever known anything to in the industry. Navigating that hype, especially when it's all you see on social media, is not easy, particularly when it promises that it's going to change every aspect of the job you have known and loved for the last 20 years. So what does this mean for me? Well, as I've literally just said, change is nothing new. In fact, as the old adage goes, it's the only constant. And AI is just the latest tool that we need to get to grips with. This one does feel a little more fundamental, however, and I will admit I am a cautious adopter, but I am open to seeing how it can improve my workflows and processes. And that's why I'm here today, to share some of my real-world experiences of my dabblings with AI as I worked with the team at Tillo as we embarked on a journey into the world of event sourcing. So today I'm going to take us through the Tillo model, brief introduction, so you can get a concept of some of the challenges we were facing. Then we'll deep dive into events. We'll look at some domain discovery, the design of events, and also code implementation. And I'll finish with some final thoughts. So the Tillo model. Tillo model. At the centre, at the heart of the Tillo model is the Tillo gift card API. To the left, we have our buyers. They integrate with our API. And to the right, we have our suppliers. We integrate to suppliers to obtain the gift cards that the buyers are ordering. And of course, we have multiple integrations to multiple third-party suppliers. So this is our basic model of business. It's a financial process, and it's our core critical path. And actually, there's two transactions going on here. There's the one on the left between the buyer and Tillo, and there's the one on the right between Tillo and the supplier. And at this simple stage of model, we store one row per end-to-end transaction. So one row in our sales table would contain the data for both the buyer transaction with Tillo and Tillo's subsequent transaction with with the supplier. Now, as I've mentioned, our application has evolved over time. And over time, we've modified our product offering. And one of the things we have introduced more recently is a product called Choice Plus. Now, when a buyer purchases a Choice Plus, we don't actually need to reach out to us suppliers because we issue Choice Plus ourselves. And the Choice Plus is essentially a link, a URL that the buyer then provides to their recipient, who can then take that URL, load it in their browser, and redeem to the value of the link for one or more gift cards of their choice. So hopefully from this new picture, you can start to see how maybe we're changing a few things about how our basic model works here. We've still actually got that one transaction between the buyer and Tillo when they purchase a link, but now we've got end transactions occurring on the Tillo to supplier side, and not necessarily at the time the buyer is purchasing the link, sometime later. So we've got this other path into our API from the recipient path. So I'm not going to get into the detail of this, but I'm sure you can imagine that this made the data storage more complex. And over time, what that's left with is an inadequate model of our financial business process. Constrained data structures, which were hampering some of our internal teams like finance, accounting, etc. A mutable history, because of course that sales table's got a status column which can be changed over time. And limited traceability between transactions that were occurring. For example, link transactions to do with redemption Choice Plus, for example. So what did we want? Well, we wanted the opposite of these things. We wanted a better model of our financial business process. We wanted a flexible data structure. We wanted an immutable history. And we wanted full traceability. So what we really, really, really wanted was events, or more specifically, event sourcing. The ability to construct the state of your application at any given moment in time from events and the data that they carry. Now, I don't know how many of you in the room have ventured into the world of event-driven architectures of any kind, but when you first start out on that journey, the first thing you typically do is look at the model that you need to fire events from. So here we've got that the two journeys of the buyer purchasing a Choice Plus and a recipient redeeming that link for a gift card brand. And looking at those models, we need to identify what's happening. What are the events occurring in the system? So doing that, we have a Choice Plus ordered event where the buyer orders from Tillo. We have the Choice Plus issued event where Tillo issues the Choice Plus to the buyer. We then have the recipient requesting redemption, at which point Tillo needs to reach out to the supplier to order a gift card. The supplier issues the gift card and Tillo fulfills that redemption request to the recipient. And this is a great place to start if you're thinking of going on the event-driven journey. This is known as a process known as event storming, and it's a brilliant process. It's like brainstorming, but with events. And you can do this with both technical and non-technical colleagues, where you can draw out what is happening in your system. And it really helps to start defining the events that you're going to need. So I would advise anyone interested to look into event storming a bit more. But we could draw out the events that were occurring in our system, but we needed to learn a hell of a lot more at the outset of our journey. We needed to do some domain discovery, and we needed to do this in a couple of ways. We needed to do this first from the business domain side. So for us, that was the financial world. And we also needed to do this from the technical domain side. We needed to learn a lot more about events and event sourcing. And how did we do this? Well, of course, we worked with our teams internally, with our finance team and within our own engineering team. But this is where we introduce our new friend, Gemini. So Tillo has a Google Workspace, and therefore our access to Gemini was the easiest route in, I guess, to use. So we use Gemini significantly through this project, and that's what I'll be talking about using today. So we're starting off with our domain discovery and our business domain specifically. Where did we start? Well, we started with human conversations, because human conversation still matters, but it is quite useful to have AI transcribe them. Actually, my first sort of experience of having AI in the workplace was seeing meeting notes transcribed by it and being completely amazed at its ability to pick up on every little sort of thing that we were talking about and then summarize it. So yeah, AI transcribed meetings, very useful. But through these meetings, we were starting to pick up various terms, terminology, concepts that, of course, we had limited time access with our finance team. So we took away things that we needed to investigate further. Things like double entry accounting, a journal, a ledger, cost of sales, all sorts of things. So off the back of these meetings, we then started to explore the subjects with AI. Some of the first questions that we asked: please, can you explain in simple terms what a financial ledger is? Yes, I'm polite to my AI. And then, what is a journal and how does it compare to the ledger in a financial system? And over time, we started to learn quite a lot, actually. So I'm going to start with a few things that we learnt, and specifically first with the journal. So what is a financial journal? So at the bottom here, you can see the super simplified version of our Tillo transactional flow where the buyer is buying a gift card. And what we learned about a journal was that it's a chronological record of every financial transaction that occurs on a system. So in this example of our transactional flow, there's 2 journal entries. The first one, where the buyer purchases from Tillo. So my example here is, imagine you've got a £10 face value gift card. The buyer has a 10% discount, so they're paying £9. And Tillo, by the way, this is not real world, would have has got a 50% discount, and so is paying the supplier £5. So that's my example use case here. So in that first journal entry, you see that the buyer is paying Tillo, debiting from their buyer funds £9 into Tillo's gift card sales of £9. And the second journal entry sees Tillo incur a cost of goods sold of £5 and a liability to pay the supplier £5. And if so you can see that's the first and the second stage of our transactional flow. We might just extend that example. So we've now imagined there's that whole process happens twice. So 19th, 20th of February, the buyer has purchased a gift card yesterday and one again today. So that's what a financial journal looks like. And part of that financial journal is that every entry in the journal must have a debit and a credit. And here we see the debit of £9 and the credit of £9. And this is so that they don't lose track of any money through the system. And that's the concept of double entry accounting. Next, we learned about account types. So you can see 3 different types of accounts on screen right now. We've got liability, income, and expense. Liability and income, quite easy to understand from my basic concept of knowledge of my own bank account, I guess, debiting and crediting money. With a liability and an income account, when you debit money, the balance goes down, and when you credit money, the balance goes up. The challenge comes when you start learning about expense accounts, where the reverse is true. But I typically think about it as if you're spending money, then you're debiting money and your expenses have therefore gone up. But yeah, we learned about account types. And then finally, we learned about a ledger and how that is very much like your own bank account. If you log into your online banking and you see maybe you've got 1 or more accounts there, it will give you the overview of your debits and credits that have occurred over time and your current available balance. And that's what essentially a financial ledger is. It's a summary of a given account. We've got 2 accounts here as examples, and the balance of those accounts at any given moment. So what do we learn from all of this? Well, the fundamental learnings we took was that firstly, the journal is essentially an event store. It's the chronological storage of every transaction that's occurred over time. And the ledger is a projection. You can produce this output based on the events in your event store. So we started to draw lines between the business domain and the financial world and our event domain and our tech world. So let's now think about that tech world and where and how are we going to store these events? Well, where do we start with this? Well, once again, we started with human conversations. It's super useful if you are lucky enough to work with a team to talk to that team and see what experience they may have of working with different systems in the past. So from those conversations, we had systems such as Kafka, Kinesis, DynamoDB, EventBridge come up. And of course, once we'd collected those things together, we could then explore those things further. We would ask questions such as, please, can you provide a comparison of Amazon Kinesis data streams and Amazon managed Kafka streaming in 2025? And what Gemini was super useful for was producing summaries and comparisons. So something like this, so where we've got Kafka, Kinesis, and EventBridge compared with various different aspects, and obviously with more detailed knowledge and information, we were able to ultimately make a decision. Spoiler, we went with EventBridge. I will come back to that. But in the meantime, we did a lot of experimenting. We experimented with Kafka, we experimented with Kinesis, we experimented with EventBridge. And Gemini was super useful once again in providing example code that we could use to get Kinesis running locally, send to EventBridge, etc., etc. As I said, in the end, this is the architecture that we ultimately chose. We chose to emit events from our Laravel application to AWS EventBridge, from where it would go into Kinesis Firehose, and then onto AWS S3 as our event store. And then as an example, at the end there, we've got Snowflake, which is a data analysis platform. But today, moving forwards from here, I'm literally just going to talk about this bit, the Laravel application and our emission of events. So sorry for any of you that were hoping I would go that way, but unfortunately, there's not time for that today. So we're just going to stick with the Laravel application and sending out to EventBridge. So after all of that, we'd learned about our financial domain, we'd learned about our tech domain that we were working with. We now needed to start thinking about our event design. What on earth were these events going to look like? So we needed to think about event structure, and we needed to think about event content. Starting off with structure. And when you send event payloads into AWS EventBridge, the first thing it does is it actually adds an envelope itself. And you can see all the keys of data that it adds here. But you as the sender have control over 4 of these keys. You have control over detail type, which is essentially the name of your event, the source, which is some identifier about where on your application the event has come from, a list of AWS resources if necessary, and also the detail, which is super key because that's where your main payload of data will be stored. So we're now going to focus on that detail, what we put inside the detail. So we then devised a Tillo envelope, and it can comprise of the following keys. So we start with an event ID, this being a unique identifier so that any consumers of the event can know if they've seen this event before. We then have a timestamp. Now, it's interesting to note, you may have seen in the previous slide of the AWS structure that they put a time on the event. That is the time that event hits the AWS event bridge. That is not the time that that event was actually produced. So our timestamp here is to 6 decimal places of when the event was produced within our system. And this helps with things like ordering if you're using a solution like we are with EventBridge. The next thing is aggregate ID. Now, this is the thing that's going to help us solve our traceability of our connected transactions. So in that example, say, of a choice plus being redeemed, every transaction, every event that is fired from our system through that process would carry the same aggregate ID. And so if you're working with something like Kafka or Kinesis that has shards or the other word that I can't remember, partitions, that's it, shards and partitions, then you can fire and you can direct any events with the same aggregate ID down the same shard or partition. And then we have a correlation ID. This is much more about observability and a single request response process. So if you're working with multiple services, for example, and we do have a couple of different services that may be used as part of our transactional flow, the originating service, the one that's hit first, can generate a correlation ID that it then passes to the next service, and then that passes through the whole request lifecycle. So you get an observability trait from that that it can be useful for debugging, etc. So then we get to metadata and data, and this is where I'm going to focus from here on in. And metadata data, what goes where? So in an event source system such as this, how much data should be considered environmental business rules versus data that is included as part of an event? Again, Gemini is super useful in summarizing and really driving home the purpose of each of these elements. So data being the fact, the single what happened, metadata being the context, the who, where, how, why, the contextual information of an event, and then also important, excluded. So things that shouldn't be included in an event. So things like changing business rules, example, how a value is calculated. So now we have the basics of the idea of our event structure. We now need to start thinking about our event content. And to do this, we return back to our financial journal and the idea that it itself is a good representation of an event stored. So we've got two entries in our journal here. So let's think about how we can represent those entries as events. So one of the first things we were thinking about was, right, we got to get this double entry accounting business right, otherwise our finance team won't be happy with us. So do we do this? Do we create a different event for a debit and then a credit? Immediate answer, we definitely do not do this. You do this. You ensure that a money movement event contains both your debit and your credit. You also, if you're working in a financial system, you'll notice here that the amount is in integers. Do not work in floating point numbers. If you have done, you will know why I am saying this. If you haven't, avoid the hell that can bring. So 900. So we got to this point. It's like, okay, debit and credit, but there was yet one more step of our learning that needed to occur, and this was key for our understanding. So what we actually found out was that the key principle of double entry accounting is that the debits match the credits, and there can actually be multiple debits and or credits in a money movement. So the example on the screen now is an example of something that we have in the UK. There's a concept of a single purpose voucher for a gift card. It's something that can only be used on one particular product when redeemed, and is therefore subject to VAT at the point of issuance. So what you've got here is us debiting the buyer funds by £9 and then 2 credits. One credit of £7.50 to Tillo's gift card sales, and another credit to an input VAT account, which is VAT that's reclaimable, of £1.50, because that sale is applicable, has a VAT application to it. And so what we ended up with in our event content was an array of what we refer to as money movement legs, where each leg was either a debit or a credit, and all the debits must equal all of the credits. And if you do that, you meet the criteria of double entry accounting. Moving on, another thing Gemini was super useful for was giving it scenarios. I'm sure you will understand that I've given you a very basic overview of the Tillo model today. Under the hood, there are all sorts of different scenarios occurring, and this is typical of most applications. We've got different stock types. We've got a bulk buy feature. We've got different financial relationships. We've got the cancellation process. We've got different charging mechanisms with suppliers. We've got intercompany payments, and we've got international payments. And it was great to be able to give Gemini scenarios of these examples, and for it to produce back to us example events as to, well, this is how you might represent this scenario in an event, in your event structure. Super useful. Another thing that was very useful was to get Gemini to act as a consumer of your event. So you could ask Gemini to produce a projection based on some example events. And this was really helpful so that we could see that what we would kind of envision as maybe an output from our events was actually possible to produce. So here we've got, if going back to our example of those 2 purchases of gift cards, you've got what happens after each of the 4 events have passed and what the balance of each of those accounts is at the end of that process. So Gemini can act as a consumer, very useful. I couldn't put this presentation together without mentioning naming things because, you know, we're developers and we like naming things. So here's an example of where I use Gemini to help me name something. Now, we ended up with an account node where this is what we started with, classification and type. What I wanted was to change the word classification to type because that made the most sense. The account type was income. But that meant I needed to change the existing type key to something else. So please can we redraw our example event, and in the account element, change the classification key to type and change the existing type key to something that makes good sense. The first thing it came up with was name, which I didn't like. So is there another word other than name that we could use in the account element key that represents the value of the specific type of account? It came up with code, and I was happier with that, and we actually did go with code. So yeah, naming things. Finally, the last thing I'm going to mention about content is documentation. So we use JSON schema to document our structures and our content of our events. And I didn't know anything about JSON schema before starting this project, but Gemini taught me about it, and it was also super useful in validating the JSON schemas that we produced as well. So now we know what the structure and the content of our events are going to be. It was time to turn our focus to code implementation. And again, 2 lines of thought here. Firstly, event types, and secondly, event emission. So event types. To explain this, I'm going to take us back to our simple Tillo model of a buyer purchasing a gift card. And I'm going to introduce you to the 4 account types over on the right-hand side here of buyer funds, gift card sales, cost of goods sold, and supplier payable, and their starting balance. So the only account that's got a balance at the start is the buyer funds. It's got a balance of £100. And we're going to walk through this process, the buyer purchasing a gift card, and we're going to see what happens to the balances of those accounts on the right-hand side. So before I get to that point, I'm just going to say that previously we've talked about there being 2 events occurring in this flow. Now I'm going to change that, and I'm going to say there's actually 4, and you shall see that as I walk through this. So the first thing that happens is the buyer gives us an indication that they want to buy a gift card. Now, at this point, they haven't got the gift card yet, but they've given us this indication that they want to buy it. So what we must do is we must debit their buyer funds by £9 to prevent them using that money on anything else. So they then have an allocated balance of £9 and an available balance of £91. Equally, our gift card sale account has a pending balance of £9. Essentially, it's like a cheque that hasn't cleared yet. It's incoming money that hasn't quite landed yet. So before we can return the response to the buyer, Tillo needs to obtain the gift card. So we now need to reach out to the supplier with a supplier purchase allocated event. So we fire this before we communicate with the third-party API. This is our indication that we are accepting we're about to incur a cost or expense of £5, and we'll need to be paying the supplier £5. So you can see that both of those cost of goods sold and supplier payable have a pending balance of £5, remembering that that cost of goods sold is an expense account where the balance goes up when you debit money. Okay. So we now reach out to the supplier and all's gone well and the supplier comes back. We can now settle that supplier purchase event. We can settle that supplier purchase. So the available balance of both of those cost of goods sold and supplier payable is now 5. And the final one we do is the buyer order settled, where we return the gift card to the buyer. And so our buyer funds no longer has an allocated balance. It just has an available balance of 91. And our gift card sales now has a balance of £9. And so when I talk about event types, what I really mean is the concept of an allocation event and a settlement event. And that's what we are representing here. So you allocate money, it hasn't landed yet. When you've done the thing that means the money has landed, you can settle the event. There is one other event type that we also have, which is allocation reversal. I'm not going to get into that today, but as you can probably imagine, we use that when things don't go quite right and we need to reverse things. So we're just sticking to the happy path today. But now we've looked at that, I want to take us back to this very first event, the buyer order allocated, the point at which the buyer asks to buy a gift card. Now, what do we do at this point when the buyer asks us? Well, the very first thing we do is ask the question, does the buyer have enough money to do this? Obviously, if they don't, then we just give them a response in the API saying that to that effect. But let's say they do have enough money. So the next thing that we need to do is we need to reduce the buyer's balance in the database, in their buyer funds. But we also need to send the buyer order allocated event. And we now introduce this condition that both of these things must be successful or neither of them should happen. Why we say this is we want to ensure transactional consistency within our data. We do not want to fire an event to say that we've allocated this buyer order and then the update to the buyer funds table fail. And we don't want the update to the buyer funds table to be successful and the sending of the event to fail. We want these two things to be consistent. And so we can't just dispatch this event at the point we change the record for the balance. Even if we do it after commit in a database transaction, we still don't actually know that that event has gone where it needs to go. So we can't do that. Instead, therefore, we need to introduce another database table, our events outbox. And this allows us to write our event to that database table within the same database transaction that we update our buyer funds. And then, of course, we can send our event to EventBridge from that outbox table. But the point of the matter is, we have written that event to the events outbox, so we know it's where it needs to be in order to ultimately be sent to EventBridge. And what you're looking at here is the transactional outbox pattern. And it's really useful, and we have made use of it in our implementation. And it looks a bit like this. Simple database transaction, 2 database updates, or an update and a create inside the database transaction. And if either fails, then neither of them are successful. And now we've got our event types and we know the pattern that we need to adhere to. It's time to return to our Laravel application and think about the code where we're going to need to implement our events. So the first thing that we discover in our Laravel code base is that the code that has the useful data to create the events is miles away from the database transaction that we're going to need to emit the event. Great. Okay, so we're going to need a solution for this. Solution being, we need to prepare the event where we have access to the useful data, and we need to send the event when we're inside that database transaction. And so we introduced the builder we made use of the builder pattern. We have a manager class that makes use of, in its construct, a builder class. And there are 2 functions that are important here. A prepare event function, which is where the manager uses the builder to construct the prepared data, and then a send event function, which is to be used within that database transaction, that is responsible for writing that data to our outbox events table. And we created a facade to make the use of our manager class slightly easier, and we can call the prepare event in our code where we've got the useful data, and the send event where we need to send it to the outbox, from where it can go to EventBridge. Now, this EventBridge code, don't go and copy paste this. This is just for example purposes only. But essentially, it's a command script that looks very, very much like this. What we're doing is we are querying the outbox events table, collecting the events we need to send, sending them to EventBridge using the AWS PHP SDK. And then once we know they've been successfully sent, we delete them from the database table, because we don't want a database table to grow and grow and grow forever and ever. And that concludes my section on code implementation, which brings me to my final thoughts. So where does AI shine? AI shines in education. We learned so much from just asking questions of Gemini, getting examples from it, etc. It helps us with our domain knowledge no end. AI also shines in evaluation. It can review what you're thinking. It can provide pros and cons to certain solutions. It can give you alternatives when you are stuck and can't think of another option to the one that is the one that's in your mind. It can give you examples. It really helped us when we were doing that investigation experimentation phase with Kafka, Kinesis, EventBridge, giving us scripts. And it was also really useful in producing example projections. And it was helpful with validation as well when we were building our JSON schemas. That was super useful. However, I can't not mention this. I'm always absolutely right, but no, it doesn't get things right every time. Surprise, surprise. And you should not lose your ability to think. Super important. And human conversations still matter. Yes, we leveraged the use of AI in this project, but it helped us. It didn't deliver the project. What glued everything together was those human conversations. They still matter. And so I'm going to leave you with a thought about our craft as software developers. And I mentioned our craft in the abstract for this talk, and Haven't really mentioned it until now, so I thought I'd better do that before the end. Our craft as software developers. Our craft is about more than writing code. It's about complex problem solving. It's about communication, interpretation, and designing solutions that meet the needs of our users. Our craft relies heavily on our ability to think critically, to question, to reason about things, and to make decisions. In my view, AI is a support for these things, but it is not a replacement. And as we continue to navigate this brave new world of AI, hyped world of the software development, I, for one, hope that we do not lose sight of this. Thank you.
Thank you very much for that excellent talk. And I think the positive at the end, because some of us might be worried that we're going to lose our jobs, but I think we're not, because we still need those skills that you outlined. If you do have any questions, we've got time for a couple. Put it in the Fleet channel on Slack. I've got one. How long do you think AI, like as a rough percentage, how much time do you think it's saved or made you more efficient?
Oh, I'd say significantly in the area of developing what our events were going to look like. I'm not sure I could put an exact percentage on it, but a good chunk of time for sure. Yeah.
We've got a question. Did you encounter any pushback from the financial department within your company when you began relying on AI to explore your domain? If so, how did you bring them on board with the idea of using AI in this critical business area?
Interestingly, no. I think Tillo as a business is actually very open to incorporating AI into our day-to-day practices. And I would say that we leveraged AI to increase our learning at a faster rate than we would otherwise have been able to do. But we did fact check with our finance team when we had learned things. It wasn't just like, oh yeah, we know what a financial ledger is and a journal is now, we'll just carry on. No, it wasn't like that. It was very much like, we've learned these things. Can you verify that what we're thinking is actually correct here? So yeah, that was, again, human conversation, super important.
Brilliant. I mean, they might just ask AI as well, you know. Okay, right. Well, thank you very much for that excellent talk.